Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So it's my pleasure to welcome Günther Ruhe from University of Calgary. He actually holds an industrial research chair in Calgary, and he has a laboratory on decision support. And today he will talk to us about release planning. Okay.
Yeah, thank you, Tom. It's really a delight to be here. For a software engineer to be at Microsoft, so that's like being on heaven. So I'm in heaven now, and you are in heaven all the day. So you're lucky people, right? And thanks, Tom, for inviting me and organizing my stay here. And also special thanks to you for attending in person. I understood there are 10 presentations per week. That means 2 per day. So that means something already to show up in person, not just looking into the recording. So myself, I have a position, as Tom was telling, called Industrial Research Chair. So that means something that I have certain focus on not only doing research, but also trying to bridging the gap to industry, trying to collaborate with industry, and that's something I learned from my former position, which was in Germany from an applied research institute called Fraunhofer Institute for Experimental Software Engineering. Then I came to Canada about 9 years ago and started this new direction, which is emphasizing very much decision making. So it's the way to look at software development as a process and as a sequence of decisions to be made. And obviously here from the title you will see that today I will talk primarily about release decisions. There are quite a number of them. The title is a battle about for the right features, and that's something certainly obviously is of relevance. And I have done some research with all my students, supervising them over the last 5-6 years, and that's the result. And you will later see that I have recently also published a book about that, so I will give you the link to that. I start with release planning, product release planning, what and why, and then I emphasize a little bit also the portion of investing into better release decisions. So we are familiar with investments, and I will, look at this type of activity, investing into something, into the investment for decision making. Then I present you some method which is actually an investment to do this product release planning systematically. I have a case study. I will give you some further examples, and then I will revisit this investment type of approach and wrap up the presentation. So release planning, obviously, we are all familiar with that. Why it is a battle for very different reasons. So it's a battle because customers always want something new, and Microsoft products are definitely in this camp. So they are great products, but customers are never 100% satisfied. They come up with new things, with requests. So there is ongoing process of change requests or for new features or whatever. Now, how to handle all these requests and how to come up with the best feature set. So that's what I'm trying to look at from a research perspective. And you find here 2 curves. So the pink one here is basically related to the amount of functionality we are incorporating in a sequence of releases, right? So if we have any product, we have major releases, 2.0, 3.0, 4.0. We have some other releases in between, minor releases, and then typically with each release we have some increase of functionality. Sometimes it might be even worthwhile, although this is never done, to reduce the scope of the functionality, but that's certainly something which is more on the exception than the normal case. And then on the other side, we have here this blue curve, which tells us some increase in features accumulated over time, resulting from feature requests from the different. These can be bug fixing requests, and it can be new features which are demanded by all the customers and stakeholders. And with each major release, I have focused here on the major releases, a certain portion of these new demanded features is implemented into a new release, right? And the whole issue about release planning, the way I look at this is, to come up with a good decision, which are these features. And there are many considerations, as we will see, to think about that. It's a decision support, Tom mentioned. So my emphasis is, of course, when we talk about decisions, so it's not to prescribing any decision, it's qualifying the product manager in a company to have a better understanding, a better insight into the implications, the different alternatives to decide about these different sets of features which are released or shipped with a new product. So that's the story on a very high level, and we are focusing on all these transition points here, mainly on the major releases, but of course it can be applied in the same way on the minor releases. So there is, from a decision-making perspective, and that's my emphasis, as I said, though, there is a number of things we could ask ourselves, and we will think how important are they. So which features obviously are offered not only the next release, so typically we can also think of looking further ahead, next release plus one, plus two. There's always what is called road mapping, a little bit more looking into the future is something important also for the customers especially. Also, the other question is which features should not be offered in the next release, and it's not only to give an answer to that, it's typically also to give a justification. My experience with working with industry is so it gets more and more important also not only just to come up with that decision, but to give arguments, to give a justification, to give transparency to these decisions. And this is also, although this is not considered here today, when is the best time for product release? So that's something, of course, of tremendous importance. So the scenario I look into right now is that we have some prescribed release date already, and it might be some change on that. The other group of decisions relates to the replanning. When we talk about planning, and then of course the understanding is that this plan, whatever it is not fixed for the next whatever months of the next release cycle. So on the contrary, so we need to look into some possibilities to replan, because just certain new information, new demands and insights we're getting. And then the question becomes, when do we replan? How much do we replan? Which so when we replan, which features should be replaced by other ones? Because we cannot just add new features because there's always a limitation on time and resources, and how often this can be done towards our customers. So if we would, announce every 2 weeks a new change because we have found something new, that would certainly be confusing for the customer. So that is just a number of examples of decision, and each of these decisions to some extent are important, right, for business success. So that's obvious. Why it is difficult? So that's looking at this more deeply will make clear that there is a number of considerations, and here are they. Whenever we plan for releases, we have to understand the time, the effort, the quality and resource constraints around it. So that's something we need to look into. We need also to look into the objectives for what is a good release plan, actually, right? And there are many considerations, usability, time to market, the financial value, the frequency of use from a user perspective, the risk, of course. Then we need to look, okay, if we want to make this decision, do we have certain information? No, we don't. We have everything but certain information. We have uncertain, inconsistent, incomplete, fuzzy, whatever. So basically the worst case, right? And then we have, in this, to even top up this scenario, we have large scale, large size, Microsoft products are very large in complexity and size, and there's the notion that things are dynamically changing. That refers to everything, to the business needs, to customer demand. So looking at all this, maybe the reaction would be, it's so complex, we cannot do anything other than just following what we ever did over the last 20 years. But of course, my approach is exactly the opposite. So I try to, at least as much as possible, to qualify this process. So why do we care? So the Christoph Ebert, who is one of the leading figures in product management, has written the foreword to my book. And what he was doing there is asking 10 questions to product development units. And these questions are like business goals. Are your business goals aligned with the product and technology decisions, right? Each company has a business strategy, and each company, should ask, is this product and technology process and decision making aligned with the business goals? Is there alignment with the different voices in the company? Is there a clear ownership of the business decisions? What is the value, what is the impact of different features, offering one versus the other, and different releases? So that refers to the return of investment in a way. Are there any surprises and ad hoc decisions in your organizations when you look at the product release process? Is the release planning and release decision process more reactive, or is it more proactive, right? Further, how transparent is this whole process, and also how strongly are stakeholders involved into the process? And what finally he was asking in this kind of questionnaire is how resource considerations are taken into account. And what he was saying that if you have at least 4 times a true, inadequate resource consideration, yeah, that's true. It's insufficiently considered in the planning process. Yeah, it's true. There is a lack of transparency in the decision process, and stakeholders, shareholders even don't know why certain things are offered the way they are offered. And if you have at least 4 times a yes or true in this, so then you basically should ask yourself as a company, I need to do something change. I need to do something better. Yeah. Now, release planning is an important topic, but I'm not here to say that if you are the number one in release planning, somehow you're automatically also the number one vendor in any type of software product. So release planning is one important piece, but it is of course related to many other pieces. It's related to sales and marketing. It's related to understanding the market. It's related to product management in a general, broader sense. So it's just something which has to be seen always as a part from a bigger picture. By the way, I want to mention this is something which comes from a news group or a repository called softwareproductmanagement.org, where you get a lot of information about new developments and tutorials and which are made in this context. There's a number of organizations involved in that, and it's driven by I think University of Utrecht in the Netherlands, and also Christoph Ebert is a very active part on that. So yes, we try to qualify release planning. We have certain things, certain needs on that, but we understand always that this is just a part of a much bigger picture, and that's important to keep it in mind. Now, let's talk about investment. So we have, of course, all the intention to make things good. We want to make good decisions, right? So, but what really does it mean to make a good decision? That's certainly something which depends very much on the context, and it has to do with something to achieve your stated business goals. It has to do with something which can be explained and can be justified. The justification, among others, also refers to the resources or the budgets we are demanding for certain things we want to do. A good decision should be understandable. It just be transparent to all people involved or impacted by that. The impact should be known in advance, and the decision should be made at the right time, which means not too early, not too late. So both things are deviating. Of course, we never know when the right time is, but it makes sense to ask yourself for any decision, is this something we need to decide now, or is it better? Of course, that in general is true. It not only refers to release planning. And decision science is something we all know established, and the focus here, of course, is to bring, to transfer some of this knowledge into this area, in that case of release planning. We cannot afford to make good decisions by applying unreasonable effort. So at the end of the day, with all the decisions we have to make, the effort, the investment into that needs to be reasonable. And also decision making means that we have to look into a portfolio of criteria. Value versus risk is just one example for that. So there's quite a lot, and how do we make good decisions? How to achieve them? We now, let's say, we have some understanding what a good decision is. The next question, logically, obviously, is how to achieve that. And there is no silver bullet for that, by no means. But it's the result of a number of things you need to look into, and that's something we will do later on for release planning. We need a process, a well-defined decision process, and this process tells you who is involved, at which point in time the decision needs to be made, who is deciding finally, and who is contributing to that, which information is available, and which information is requested, and things like that. So I'm very much propagating to look at decision making from a process perspective, to see really, and this process again, of course, is very much linked to the overall development and business process. But it's important to be aware that these decisions are made. I mean, that's actually the most important point, to understand certain situations. This is in coding, or it's in designing, or it's in testing, or whatever it is, that there is actually a decision process happening. And that's something you need to look more deeply and more rigorously. Otherwise, you make the same mistake I did when I came here to Redmond, when I was just looking at the map very quickly, what is the best route to come here, and I thought, okay, go this way, but I should have invested a little bit more deeply, though I would have found that there is a better way to do that. So this was actually an ad hoc decision, relying on kind of gut feeling, right? And what I tried to convince you that the other way around should be applied. I typically apply it to myself. Yeah, you need to understand what is a good decision. You need to look, of course, at all the accompanying and associated processes around what you are focusing on at the moment, in our case, release decisions. You need, of course, a sound methodology. You need a good support, but this is something we as researchers typically emphasize very much. We are looking for the silver bullet, the best technology and the best algorithm and whatever, the best tool maybe, but it's just one piece in a much bigger set of requirements. To make good decisions, I think it's pretty clear when I say it, you need to understand pretty much what you're talking about. You need to understand the objectives and the constraints, and that's easier said than done. Sometimes it's very hard to really figure out which are the objectives and which are the constraints. So that is sometimes even more difficult than to solve it finally. And then you need for good decisions, you need good information, garbage in, garbage out. So if you have nothing really objective and substantial, so then it's hard to expect something reasonable in the decision space. Talking about investments now, so what do I mean by that? We are requesting and demanding better understanding of business objectives. So that does not come for free. The understanding about resources and their capacities. So that it doesn't come for free either. So resources. So we need to estimate our feature, our bug fixing activities, whatever it is. So that is an investment in the sense you need to analyze former data. All what you're doing in mining in repositories, so that is an effort, right? You do it to better understand from the past performance and to project the future with that. And that's an investment, and that qualifies in a way decision making. You need to invest to understand who are your key stakeholders. Yeah, Nachi, please.
Actually, I have a question which is actually a very interesting problem for a lot of people. I don't know if you're actually going to talk about this in future slides, but a lot of companies actually get in as on a V1. So they really have no history available.
Yeah.
So for example, a company is doing system software.
Right.
They decide to get into services. They really have no history to calibrate how their engineers are going to do what the scenario is.
Yes.
So is there a notion of comparable analysis, migration, looking at prior history of different companies? Or?
Yeah, I mean, there are certainly in this situation you cannot easily look into your own repositories if you don't have them, but you need to understand that this is important. So you need to establish at least this data collection measurement effort from the beginning. If it is immature at the beginning, important it is that you at least know that it is immature and that you start something. And why not to look across organizations, to look at something where you think it's to some extent similar, but it's better to start with something instead of saying I don't know and then I still follow gut feeling, right? But that is definitely an investment, and that's, as I see it, pays off in a certain sense if you can make this with a reasonable effort. Yeah, thanks for asking. Constraints related to business, to technology, to really understand all the constraints, the performance constraints, all the difficulties, the scalability of the product, the tremendous products developed at Microsoft. This is something you need to understand. And again, this is easier said than done. But in a strict sense, it is an investment, right? As we are investing in new design or any other things, the point is to figure out where is the break even, where does it really pay off, and to what extent. Of course, it's also investment, for example, if you do a post-mortem analysis of some projects you have done, not just switching to the next one right away because it's already whatever in the pipe, and you need to learn from your former projects to feed in the results into your repositories to allow you to benefit from this experience in future projects. Again, an investment, all the communication and negotiation of decisions, it's easier, of course, to make a decision right away, gut feeling based, and say that's the decision period, let's do it, right? Instead of communicating and negotiating with all the stakes, which is sometimes really painful, but it pays off to some extent if you need the buy-in of all the people, right? So if they are convinced and they know why this decision was made and they are convinced that this is something under the given context, preferences, that this is something meaningful, yeah, then you get probably better support for implementing this decision. So that's the part one of the investment. Now I switch to release planning, and let's say there is the first approach. This is zero investment decision, which seems tempting. That is on the fly, decision making on the fly. there is an animation. I'm not sure I can run that. Okay. Anyway, what's happening typically is that there are coming permanent change requests into this change repository on the left side. So this is a change repository here, and if the animation would be running, so you would see, oh, there's something running. Okay. So there are always new change requests arriving here, and what's happening is that there is an ad hoc decision which feature is decided to be released at which point in time, right? So this is a pretty much informal process. You have no explicit description and knowledge about the criteria. The decisions are by no means transparent. Stakeholders are, at the very best, implicitly considered. So you just, as a product manager, you just state that I know what my customers want, right? We know the reality is everything, like that. It's completely opposite. So typically we don't know what the customers want, or at least not in a way we should. And resource consideration is largely left out. So with all these decisions made ad hoc, which is zero investment, but you have a lot of trouble later on if you understand that for deciding the way you decided with all these features, you might need more time or more resources or other things, and that is typically not available, and then you need to adjust your release decision and so on and so forth. So that is the zero investment alternative, which is not a good one, I think. I'm propagating here something different, and that is a method which is called Evolve 2. 2 because there is a 1, and this is a kind of integration of former, I'm working on this. So the first paper I wrote on this was 2003 in the IST journal, which Des Grier from Northern Ireland, and over the years we made further enhancements and improvements and all this stuff. So now I tried to integrate all this, and this ended up in Evolve 2. So it's not ad hoc, it's the opposite, which does not mean it is highly formal or highly, heavyweight. It's not. It's primarily emphasizing that release planning should be made as a whole process, bringing in the right stakeholders and allowing them to contribute their knowledge at the different stages of the process. And I will explain to you what I mean by that. So we need to prepare for this process. We need to select the criteria. We need to also weight the criteria. Some criteria are more important than others. We need to pre-select the features. Change request repositories are typically, and I guess the same is true for Microsoft, in the order of thousands, if not 10,000, where certain requests are made, and we cannot just randomly or even ad hoc pick, let's say, 100 we consider are top candidates for the next release. This pre-selection is often made pretty much ad hoc, and then later on you put a lot of emphasis in the actual selection from the pre-selected features. But the whole program starts in the pre-selection, obviously. And we need to look at the feedback of the stakeholders, how they judge these features. We need to have some resource estimation in place, and then we can do something which I will explain later, which is related to optimization, to really have mapped this magic release planning problem into a quite rigorous optimization procedure. And once we have solutions, we are not yet done. In the contrary, the solutions now need to be, in a way, validated. We have here something called excitement analysis. We do some what-if analysis. So we really check about the applicability of the solutions, and we eventually might go back and change things. We see there are some, as a result from this process, there is not only one plan generated. We have a portfolio of actually optimized plans, and which one of them, if any of them is really recommended. So that's something where we perform this quality analysis, the excitement analysis. We do some what ifs. What is the degree of change if we re-weight our criteria? And as a result of all that, we might end up in saying, there is still something wrong. Our stakeholders don't really like the plans, and they have good reasons for that, because we have certain constraints not yet considered. We have maybe the wrong importance degrees of the criteria. So that all might happen, but at some iteration, you come up with a final solution. Criteria for release planning, I mentioned there is a number of them, and they are listed here: customer satisfaction, dissatisfaction, all kinds of risk, cost, volatility, time to market, there are even more of them. So what it means here is we cannot just plan for any single one of them. We need to consider them in conjunction, and the stakeholders actually are very important component in this process. So the stakeholders, of course, have a different view at the plans, more from a financial perspective, more from a frequency of use perspective, or more from a whatever risk perspective, and we need to balance this somehow, right? So that's the whole game, which is happening by the stakeholder voice of the stakeholder analysis. And here you see already a first screenshot from a tool we have here in place to support this process. And what you can see here is different candidate features. You can see different criteria like urgency, like alignment to business objectives, or certainty of information you are relying on. And you can get some input from the stakeholders from some kind of scoring or prioritization process, how important they consider the different features, and then you can rank these features by combining the different criteria, right? So that's one way to understand customer needs, and the more customer you can integrate into this process, the better the results typically can be. So the next thing we ask ourselves, there are many criteria, but how to really combine them? And that's, of course, the question where tons of research papers are already written, and you can do a lot of elaboration on that. What we did here is basically a kind of, let's say, simplification of the perfect world view. So we have features. We ask the stakeholders on their view of to the features from certain perspectives, and we have a three-dimensional scoring. N stands here for the feature number, P stands for the stakeholder. There are many of them, and Q stands for the criterion. And we combine this from asking the stakeholder on their perception of the candidate features and letting them score on a 9-point scale. That's something which has proven sufficiently detailed, and we need to really not go overboard, but should make it, of course, to some extent meaningful. Now, the stakeholders, as I said already, might have different, so that's now the procedure, how the planning function is composed, right? So that's what I'm trying to explain here. As there are many criteria, as there are many stakeholders, as there are many features, so there needs to be some mechanism how to define what also sometimes is called the utility function of all this. And the next step in this process is that now the different stakeholders with their different level of importance are taken into account by weighting them, right? The same is true for the criteria. Some criteria are more important than others, and you again integrate these things. And finally, you can even integrate or consider the importance of the different releases. So the next release, what I'm offering to the next release, obviously has higher importance than saying, this comes in 3 releases from now. This feature, I'm happy to inform you, dear customer, yes, we are planning to do this, but it's coming in the release 2012. So that's certainly something which, from a kind of utility perspective, is lower scored, has lower impact than on the total function. So what it means is we have here something like a total stakeholder feature point. So this is measured as attribute called total stakeholder feature points, and this in a way expresses the weighted combination of preference of the different stakeholders related to the different attributes, different features from the perspective of the different criteria, right? So this is a kind of additive function. Of course, you can now ask from a research perspective, why is additive, why it's linear, why it's this and that and that. You know, at the end of the day, I have stopped at this point in time because I want to convince someone even to apply that, right? And the more complex the system gets, the more unlikely it is that it is applied, right? So we can certainly say it's good enough, and that's something which is still affordable, and it has been applied actually quite often already in industry. So the next important part of my talk is what I call the diversification principle. That is part of the solution process. I mentioned already, it's quite unlikely that from solving a problem, that the one solution, whatever that might be, you know, the one solution we are proposing is the one for the real world problem. It's quite unlikely. Why? Because we are relying on uncertain information. We are relying on our bias, what the problem really is. You know, we have a lot of uncertainties, and it definitely intuitively makes sense, instead of just looking at one solution, and this can be applied again to very many things, and on designs and whatever. You know, we offer the user for this interactive process a portfolio of qualified solutions. So it's a portfolio. In our case, it's 5, what we are offering, and it's qualified. So that's really something qualified against the stated utility function, okay? So this function I just explained to you. And what it means also, we are starting with some modeling. We do some exploration. That is, in a way, the science part. Remember, this is about art and science. So we start with, I just made here a number 10 to the power of 12. So this is for a relatively small release planning problem with, I think, 25 features and planning 3 releases ahead of time. We end up combinatorially in this large size set of solutions. Now, what this systematic process and the underlying algorithms does is really to reduce this set in a first phase to a mid-size set of qualified solutions. So it's mid-size, so that's in the order of 100. It's not exactly 100, but you know, a set of sufficiently good solutions. Let's say this is 100 of them. And they are proven to be qualified, so that's something related to the degree of optimality against this utility function. Now, this is, of course, nothing the user could benefit from. What the user really could benefit from is now if you go one step further and you take out from these 100 qualified the 5 which are among each other most diversified, right? So that's like in financial portfolio planning. You try to make different strategies to bring things together as diversified as possible to have a higher chance, and that's what this diversification principle says, to offer something which is likely to be acceptable for the user. And that's the iterative process. So, you know, the stakeholder, the user, has a very important role in this iterative process. It might be that, you know, among the 5 we are offering, none of them is satisfied. And I experienced this with a company, right? So I proudly offered 5 optimized solutions. They said none of them is feasible or acceptable. And I said, why? It was the best algorithm in the world. Yeah, but it solved the wrong problem because we forgot to introduce certain constraints and certain considerations. And then we remodeled and we are determining these qualified plans, and this was then something they could live with. Here is, you know, what I just talked about. So you have in each column, you have alternative plans. They are all optimized. They are all diversified. You see this 1, 2, 3 corresponds to release 14, 15, or none of the 2 postponed for now. And you see from the whole pattern of these releases so that they are looking different, not completely different. Certainly there are certain features which are recommended in all 5 alternatives to be released in the next one. But there are some features which can be offered earlier or later in compensation to other features. Art and science, this is here art, in my view, refers to the capability of the human to be intuitive, to communicate, and to handle tacit knowledge, which is beyond what the computer can typically handle and understand. And the science part obviously refers more to the formalized description of the problem and application of computational algorithms and to generate something which is called best. And it's clear that both approaches are important because most of the problems we are facing in software are on the one side have explicit parts which can be well described by numbers, but also have a lot of what is called tacit knowledge. So we need both parts. And the only question here is how to bring the two things together. And what I tried to explain here is that in this approach I have outlined before, actually both art and science in some way have been integrated. And that's what you find here. These are the steps of this process, and I don't go into all the details of that. But you find here, let's say, the pre-selection of features. So the pre-selection of features is determined by asking the right stakeholders. That is the art part. It's hard to make a rational, objective, 100% certain choice. Who are your right stakeholders? You have about certain understanding about that, and that's certainly something which can be called art. On the other side, in science, you can, of course, do something called multi-attributive prioritization, which asks then for some scores about the importance. And the same way, resource estimation can be done, based on expert judgment, but you can, of course, apply this in a more rigorous way by bringing different experts together and trying to establish a process where they can collectively estimate certain things. And so that is, the whole idea of Evolve 2. It's very much stakeholder-centric, and you'll find here some snapshots from the tool, how these processes are supported. So this is about the selection of criteria, and you find here there are different criteria, and they have a different level of importance, and you can score on them cumulatively or non-cumulatively. You have here the actual scoring process where each stakeholder is asked to categorize a candidate requirement or feature among 9 different levels of importance. So that's something which serves as an input to understand the attractiveness of a feature. And you see here that this is done from different perspectives for different criteria, from value, frequency of use. So these are things you have upfront decided are important for you, and that's why the stakeholders are asked to provide their opinion on that. And you see here also that this is cumulative voting, that they have only a certain amount of votes they can allocate, so to stronger enforce them to differentiate between features, so they are not allowed to classify everything as of extremely high importance. And finally, another example here for this synergy is the result of this process, where you can now put together the attractiveness profile of the different features based on the stakeholder input. And this is continued here. You do the optimization, which is primarily a science part, right? So, once we think we have reliable models and data, so we run the optimization, and that is poor, in a way, science. These algorithms are highly complex. They are computational intensive, and there is, I think, no other way than considering this as science. But the next part is then, again, the evaluation of the planning alternatives. So that's something where we need the input of the stakeholders, because from being optimal and even proven 100% optimal or close to that, that does not mean that this is meaningful in reality. Again, here some examples on that. So these were the different alternatives. This is what's called stakeholder excitement analysis. So that helps you, to project the likely reaction of your stakeholders against the plans proposed. Here you find something, this is alternative 1 out of the 5, and you see here different stakeholders, and you see for this project with something like 25 features, how often they are very excited, neutral, disappointed, or very disappointed. When is a stakeholder excited with a feature? So that's when he or she has expressed, this is of high importance to me, scored it in a highest possible way, that's 9 here, and find this feature in the next release. That creates excitement. And the other way around, it would create disappointment, if not very disappointment, if the same thing would result in the announcement that this feature is postponed until whatever, right? So we just, by just counting these different configurations between what was suggested from the prioritization against what is offered in the different optimized plans, so that gives you some indication about the likelihood of acceptance. And that also gives you as a product manager, of course, a lot of information what about and to whom you should talk to explain and justify your product release plan, right? Yeah. So now let's finish this part. I need to speed up a little bit, so give me until half, right? So I try to speed it up. Anyway, I presented 2 approaches. The one is the zero investment, the other is a greater than zero investment. And you find here the different characteristics of these 2 methods. And what I tried to, of course, argue is that the investment in some form of systematic planning and replanning is paying off. And you find different criteria here for that. You can do what-if analysis. You can consider different types of dependencies between features. So these are all things you typically cannot handle for non-trivial problems in your product management. So there's a case study. Maybe I switch on that to speed it up a little bit. So the case study is from a real-world project where we have applied this, and you find a number of encouraging results. So this is, by the way, published in a journal paper on a journal for software maintenance and evolution in 2005 with one of my former master students, Joseph Momo. But from all running these different case studies, I want to share with you a few lessons learned because from each project you learn something else. And I started with Corel in 2003-04, and I mean, what they primarily emphasized as a result of applying such a more systematic is, the stakeholders were delighted. They were enthusiastic about being stronger and explicitly involved in the process, and this helped them to do it better. In Siemens, go.
Could you say a little bit about what the existing process at these companies was, so that what's the comparison?
Yeah, right. Okay, so that's in each case slightly different. So, I mean, the former case study would have told you that they have done it primarily based on Excel, looking through the collected information in an Excel repository, and then making typically a 1 or 2 person decision about what comes next, right? And let's say Corel was a very interesting and encouraging. That's how it started, because initially this was primarily driven by research interests and some anticipation this might be useful. But after we had launched some prototype in the web with this solution, which was, of course, not as mature as it is now, but they gave us a call and they said that's something we are looking for since years, because it looks like we can really organize our planning process better that way. And the planning process was, and there is another publication actually I can give you afterwards where this is described at the ProFest conference in 2004. I mean, they had this Excel sheet, but they had a low stakeholder involvement, so they basically were, if at all, implicitly taking into account. And And insofar, the result was that typically they could incorporate not necessarily more, but a better set of features, in the sense matching the stakeholder expectations as good as possible, right? Siemens, so the key experience here was that actually stakeholders don't even understand partially the features, right? So feature planning or assumes that it's clear. It's probably clear to the inventor or to the developer what the feature means, but bringing this across to the stakeholder and to the user especially, and to show what the user benefits from that and how easy or difficult it is to use it, I mean, that's a different story. And there were many things where in the forefront, actually, from this analysis, where they were asked to prioritize things, they got the understanding that they don't understand it. Yeah, and there are other, risk mitigation was something we learned from the trial project with WestJet, where they were running quite a number of what-ifs, and from this comparison, they found out that certain risks might be mitigated one or the other way. Stonesoft in Finland, a security company, they in a way learned that with these optimized plans, they have a higher likelihood that the plans, once implemented, are stable and don't need to be changed very often. And Siemens Audiology, an ongoing project, I mean, they really in a way utilized this technology in the best possible way, because they incorporated worldwide their stakeholders, and based on this knowledge they came up with a much better product strategy, and they implemented this whole process iteratively, so they did not just implemented the optimization or in a one shot, but they did it really by subsequent iteration and reduction of the set of candidate solutions. Now, okay, so there are many other examples. Again, I don't need to go in all this detail, but what we have seen is basically a process here where from some, and this can be generalized, of course, beyond release planning, we start with a consideration of a software engineering decision problem. We model this in the best possible way. We get something formalized, and then we try to offer decision support and hope that this is implemented. And the key thing from this Evolve 2 approach is that we really facilitate the early stakeholder involvement, and we qualify the input this way, and this helps us to solve the right problem, not only solve the problem right, but solve the right problem, right? So we get an early validation of what we are looking at is meaningful. It matches reality, and that was the key point here in this Evolve 2 method. It is also applicable to of course, planning for multiple products, where you try to synchronize release cycles. Microsoft Office Suite is a classical example. If you plan them, of course, individually, each product of the suite individually, you have different cycles, and typically it is not a good thing to offer the individual product in different release cycles. So you need to synchronize them, and that offers you a better chance. Of course, this synchronization doesn't happen by chance. You need to invest, and this makes even the problem bigger, but I think there's a good payoff. And there are other examples here. In one case study, we could demonstrate substantial cost savings from applying scheduling. It falls under the same paradigm, and it's also applicable to the whole process of replanning with the questions I have already started at the beginning. Now let's reconsider investments, and there is a good paper or book from Harrison from 1987 who basically asked the question, how much should we invest into the perfection of information? And there is this Pareto probably principle that, for getting certain good information, let's say 80% good, we only need to invest 20% of the total amount of effort we would have to invest to get the 100% perfect information. So it's a curve. The cost curve is growing here. The benefit curve from getting better and better and better and better information at some point in time is saturated. So we don't get anything, the increase getting from this level of perfection to this level of perfection is relatively low, right? So that we can easily, as an honor discipline, we can create something like a cost-benefit curve, and there is a sweet spot where perfection of information is paying off, and that's what this message here is to make. And there is something like an ROI, and this ROI in that sense really means how much should I invest into better decision making. And of course we need, I don't give a formula in general what is the perfect information for any type of problems, but what I'm saying is it's worth to look into that. There are a number of pros what we can get out of this, and this is pretty much along the lines we have already discussed. So it's we can expect higher transparency, understandability. We reduce the impact of human bias. We reduce the risk of failure, and we have overall a higher chance of also business success. The cons are we need to, of course, invest a little bit more. We need additional effort. We eventually need to become familiar with certain technology or with a tool or things like that. But overall, this effort is reasonable and affordable. Wrap up. Fallacies in release planning and the rebuttal. So there are certain things which I heard over the years. Release plans are not really needed. Okay, I think what partially was demonstrated that qualified plans boost business and development. The fact that the input is uncertain is not an excuse to do it, even though maybe some estimates are not as reliable as they maybe should be. But exactly what is achieved from this more systematic and rigorous approach is to reduce the impact of uncertainty. Right? There are many techniques like what if and simulation and many other things where we, of course, cannot overcome the uncertainty of the input, but we can reduce the impact of this uncertainty and make clear in which range eventually we can behave in the best possible way. If my planning problems objectives are not well defined, so now that's something fundamental, independent of release planning, obviously, if I don't know my planning and business objectives. And if things are changing rapidly, yes, but that's exactly a reason to run this, because once you have established this kind of description, you can rerun it, and thus you can react to changes much more faster and much more qualified. Yeah, so there's this, the story I wanted to share with you. So the message is basically that, yes, investing into systematic planning processes for coming up with best possible releases is worthwhile. We have certain benefits we can expect. It was partially demonstrated also in case studies. I have shown you one of them, what the benefit is. And if you are now getting very interested to read more about that, so I can recommend you the book, which I have not yet seen. I have worked on this, I can promise, over 5 years, and Tom was one of the most critical reviewers. Thanks, Tom, again for that. I wish I could present it to you. This was the best moment I could imagine to handle this over, but I'm still waiting in my hotel to get it delivered by courier, so maybe tomorrow. And but you will get one for sure, yeah. Thanks for sharing this with me, and I'm happy to answer and discuss any questions you might have.
One of the things is in Agile, they have these things like burn down charts.
Yeah.
Which basically are more like, estimates that, program managers to some degree, they have a handle on how much work is left.
Right.
So is it possible to actually develop any machine learning models or anything statistical that would use the amount of remaining work effort and tie it to the actual success of a product, and then calibrate and say when there are certain trends that are observed? I mean, it's just a thought. I don't know if this will even work.
Yeah. So I have looked into, of course, agile technologies as well as Scrum, use of this burn down, and what the main difference is, of course, fundamentally what is different here is that for each sprint, you assume already you know what the features are you want to implement. Okay, that is of course completely opposite to what I'm doing. Because that's that decision, the most important decision. If you pre-decide already that one, and you try now then to find the right sequence, how to implement them, so then your decision space is basically reduced dramatically already, right? The other thing is, typically you just look one sprint ahead of time, and this is a short 2, 3, 4, maximum 6 weeks ahead of time. That is again a strong limitation into the decision space. You do not look into any stakeholder preferences. So I in the book again there is a chapter where especially this is discussed. What it is all about. I mean, it's really a trade-off. So there are definitely good things in looking at development from an agile perspective and running Scrum, but in that case you have, of course, a shorter time horizon. So that means your information is more reliable compared to looking for the next release, which might be 6 months or even more from now, right? So you cannot expect. Insofar, I'm a little bit against to directly compare the two. That's like apples and oranges again, because it's a trade-off. You have a higher time horizon, so consequently you have, of course, higher uncertainty, and then you have in the agile you have a relatively well-defined world, and you can do nice things, but the whole scope of optimization is reduced here, right?
So let's say I'm a project manager. My favorite universe consists of MS projects and tasks and their dependencies and running Monte Carlo simulations. At what level do I integrate my sort of everyday work routine into what you are?
Yeah, very good question. Yeah, thank you. I have not asked you for that, but that's a perfect question. Yeah. Two-stage process. Number one, you plan the features, which is one level above what you do in project management. In project management, you handle tasks, you handle people, you schedule, you have a time. I mean, the thing I have talked about here initially was on a feature level. A feature is a kind of mini project. It depends how you define a feature, but let's say it's a kind of mini project. What I have not talked here about, I have presented it very, very quickly on one of the slides of the application, is also a subsequent staffing process where you now look into really the individual tasks to realize certain features. If this a feature is a mini project, so we can certainly define a certain task related to design, to certain implementation activities, to certain testing, right? Putting this all into one box, then you can run again in an optimized manner, scheduling and assigning people to tasks. In the model we have done, and actually there is a component in ReleasePlanner in that, we have even the capability to model the productivity of different developers, because developers are not equal, right? There's a huge difference, proven empirically up to 1 to 20 in certain development activities, right? The one person who is 20 times as good in something compared to another one is maybe 20 times as bad in another one, right? So the only point is they are not equal, right? And it makes sense to try to assign, and that's something I have partially done also with Tom, right, in defect boxing, to assign the right people to the right task, and also, of course, looking at all the schedule. Now, coming back to your question, Microsoft Project. So the results of that can be now transferred into Microsoft Project, where you really monitor the execution and fulfillment of all these tasks, right? But I think without considering Microsoft Project as any competitor product. I mean, it is out of scope, of course. But our, of course, optimization-based approach is much more, in a way, looking at optimality. It's of course, I would say, more intelligent. It's less good in really the interactive monitoring capabilities a Microsoft Project has, right? But we can export it, and in the book, again, you find screenshots where the results now you can handle as a project manager within Microsoft Project. We export the files in an XML format and then can import it into Microsoft Project. Yeah.
I wonder if you could just talk briefly about how the what-if analysis works. Like, is that a formal process? And like, how do you provide like tool support for doing that kind of?
We meet this afternoon, right? So I can demo this. I don't want to do this right now, but in principle, I could, but what's happening is, I mean, what if? What does it mean? You have a certain instance of your problem, right? And you can run this process, and the tool generates you certain optimized and qualified plans, right? Now, related to this, let's say, reference or baseline problem-solution pair, right? You now talk about what if. What it means is you can vary basically any parameter in your problem instance. Is it the capacity of your resources? Is it the weight of the criteria? Is it the weight of the stakeholder importance? Is it whatever, right? And you just adjust the parameter and rerun it, and you see the differences in the results, right? So, and that is a formalized process, by all means. You see always the results for the changed parameters, and you can do it as often as you want, and it takes you seconds. But that's very powerful, of course, if you see that the plan you have generated for your, let's say, baseline or reference instance remains the same, even if I just modify certain parameters to some extent, like a sensitivity analysis, right? That's a very valuable result, and that can be done in a straightforward manner.
Regarding design diversity, I think on slide 18 you had this diagram, right? Like we start at 10 to the 12 possible solutions, and we sort of filter down. Is that an explicit statement about the process? Like, do we start to sort of, you know, at the beginning of this meeting, do we start with like, let's consider all possible solutions and then rule out things, or is this?
No. This is just to show you, you know, the stepwise reduction of the problem size, what we consider, right? So that's a way I would recommend decision making. So we do not just go from a problem we do not fully describe to one solution and then we are done. So we try to really reduce the solution space, and in this process, obviously, we get more and more information, right? Like effort estimation. We do it at the very beginning, and then we later refine our estimates, right? And insofar, this is more, you know, a principal way how it is done. And of course, the numbers can be any other ones, but you see it's order of magnitude. You reduce the space, and you get more and more towards meaningful results. And meaningful really means applicable to the actual problem, right? This answers your question?
Yeah, so I guess you're picking sort of candidates from different clusters, right?
Yes. I mean, this 10 to the power of 12 never are explicitly given, right? So they are, in a way, you know, if you have this, the 10 to the power of 12, as I said, comes already from a relatively small, imagine you have 3 releases, you have one feature, and you don't know when it will be released. So you have 4 options to put it into release: 1, 2, 3, or postpone, right? If you have 2, you have already 4 to the power of 2. If you have 25, you have 4 to the power of 25. And that's why these 10 to the power of 12. But you never elaborate along those 10 to the 12, power of 12, right? So you have much more intelligent search algorithms to come directly down to a relatively reasonable set of 100. All of them are somehow pretty good. And you know what goodness means. And then within this reduced set, you look at the structure of them, and you can do any kind of distance metric between them, and then look, oh, they are pretty much different, right? Although they are, in a way, formally of the same quality. And I think that's very important. And I think that, as I said, so this is applicable to many other problems, in software and beyond. Right?
Okay, so let's
Yeah. Thank you very much again.